Today we want to talk about odds and probability. I just want to do a few more problems with you. I'm going to start with this one. The number of employees by gender and job status is summarized above. If a person is selected at random, let's find the odds of selecting a woman. So looking at the chart, I can see there were 170 women. So I want to put the 170. And then what would not be a woman would be if we select a man. We can simplify this, kind of just get rid of the 0. So now I have my odds of selecting a woman from this group as 17 to 23. Part B, let's say, what are the odds of selecting a part-time employee? Okay, looking at the chart, I see there were 150 part-time employees and there were 250 full-time employees. Just like the last one, I'm just going to cancel out the 0. 15 and 25, I could divide by 5. So divided by 5, I got 3 to 5. There's my odds. Okay. C says, how about if we select either a woman employed full-time or a man employed part-time? So I'm going to go over to the chart and look at a woman employed full-time. Woman full-time, 65. Or a man employed part-time, there were 45. So we need to add that together, 65 and 45. That gives us 110. And then what do we compare that to? Well, we compare that to what's left, to not being a woman full-time or a man part-time, which is 180 and 105. So there's 290. Looking at these one more time, I see that 0, so let's cancel the zeros on both of them, and we say our odds would be 11 to 29. Okay. Let's look at going from probability to odds. So if the probability of A is A over B, then the odds of A will be A to B minus A. So I could write it this way too, A to B minus A. This is the odds written as a ratio. All right, let's take an example. So let's say that I gave you the probability of earning an A in a class is 9 to 20. So I have the probability of getting an A is 9 over 20. That means the odds of earning an A will be 9 to 11. So this 11 was 20 minus 9 gives me 11. So you can see I had 9 to 20 minus 9 gives me 9 to 11. Same thing, I said, well, what if the probability of failing a class is 1 over 6? Then the odds of failing the class will be 1 to 5. Same thing again, I look at one way to fail. 6 minus 1 would be the ways to pass, so 1 to 5 would be my odds of failing. Let's look at this last one that says the probability of getting a B in a class is 10%. So I'm expressing the probability differently this time. I'm giving it as a percent. So 10% we know is 10 over 100. That's going to help me get the odds. So this says 10 ways to pass. So here's my 10 ways to pass. And then 100 minus 10 gives me 90. So we have 90 ways to fail. Oh, actually, to get a B. Sorry, I didn't mean to say to fail. So this would be the percent. So I had 10 to 90. So 10 ways to get a B, 90 ways not to get a B. 10 to 90, let's drop those zeros. That gives me 1 to 9. All right, let's look at this picture that shows us the eye color demographics in the United States. So it says 32% of people have blue eyes, 15% have hazel, 12% have green, 16% have brown, and then 25% have dark brown. Let's calculate the odds a person has blue eyes. Okay, so blue, it's at 32%, so 32%, I like that idea of doing 32 over 100. So I will say for 32 ways to have blue eyes, and then 100 minus 32 would be to not have blue eyes. This says we have, let's see if I can put this in here, 32 to 68. All right, so we need to say, well, can we reduce that a little? Can we make it a little better? We can divide by 2, which would give you 16 to 34, but look, you can divide by 2 again. That gives me 8 to 17, so 8 to 17 would be the odds we would want to express. What about, what are the odds a person does not have green eyes? Okay, so green eyes is 12%, right? Which means 88% are not green. Just subtracted from 100. Okay, so not green, 88%. 2 green, right? So I have to say this 88%, which was 88 over 100, but we kind of know already there's 88 ways to not have green eyes to the 12 ways to have green eyes. You can divide both of them by 4. I get 22 to 3. One more with this one. What are the odds a person has brown or dark brown? Okay, so brown was 16, and then dark brown was 25. So we add 16 and 25, we get 41. So here's 41% chance of having brown or dark brown. If I look at 41 over 100, it says 41 ways to have brown or dark brown. Then I do 100 minus 41 is 59. That one doesn't reduce, so we just leave it like that. Really want you thinking though, when you see the word odds, you're looking at how many ways can I do the event versus how many ways I can't do the event. Make sure your answer for odds is not the same answer you would give if you gave probability. Let's look at another kind of example. This one I said a survey of 500 people revealed the number of people who owned a dog. So it tells you if you had 0 dogs, 1 dog, 2 dogs, 3 or more. I totally made this up. But I want to find the probability the person has at least 1 dog. So I'm going to do probability and odds on this one. I like this phrase at least, and I want us to think about it. At least means 1 or more. So it could be 1, it could be 2, it could be 3 or more. But what it is not 0, right? So it's not that. Let's quickly look at 320, 125, 40, 15. Remember we said that was equal to 500, so this is our 500 total. So at least would be 500 minus 320. So you have that choice that you could add up 125, 40, and 15, or you can just choose to do 500 minus 320, which will give you 180. So 180 people have at least 1 dog. Because this says probability, I want to do 180 over 500. Let's first say that as a fraction, and then we'll say it as a decimal. So this was 9 over 25, same as 0.36 or 36%. Just depends on the phrasing of, like if you have to put it into as an answer, if it asks for something particular. So as a fraction, as a decimal, as a percent. Right. Same thing on this part B says, let's find the odds a person has at least 1 dog. Now that I'm looking at odds, I say, okay, I know that 180 had at least 1 dog. 320 do not have a dog. Here we are back to this odds where I can cancel the zeros. I have 18 to 32. I could divide by 2. That gives me 9 to 16. Again, we can see that big difference between what does a percent look like to have a probability, even as a fraction, versus the odds need to look different. And you can see that 9 and 16 gives me 25.